and welcome to this tutorial. This learning material is about the methodology called Methods for Surveying and Diagnostics of HVAC Systems in the Existing Buildings. This material was created for the European research project called Harmonized Building Information Speedway for Energy Efficient Renovation, acronym BIM-SPEED. The methodology is structured in 4 sections. The first section highlights some basic information about HVAC systems in residential buildings. Second part of this methodology details types of data, technologies, and methods to acquire that specific data. The third part shows how machine learning can be used to transpose the data collected into a BIM model. The last part of this methodology details how to use 2 Autodesk Dynamo scripts to check if the modeling was done properly in order for the HVAC system to show correct items. The purpose of this methodology is to understand what data can be collected and how can it be used for the BIM use cases inside this methodology. The tools developed for this project are designed with the purpose of assisting BIM modelers to optimize their time spent on the modeling activity. The methodology is addressed to engineers that go on site and collect the data. This methodology will offer them an overview of types of data that can be collected from the site. For the BIM modelers, these guidelines will offer an impression of how the information received from the site engineers can be connected and used to create a 3D model and to assist on the BIM use cases. The main topics of this methodology are as follows: the data collection from the existing buildings HVAC, the digital recreation of HVAC models, completeness of a HVAC BIM 3D model. The data collection from existing buildings for HVAC systems will identify the techniques, the technologies and methods to use and collect the data. The guideline focuses on the main types of data that we identified as being important in order to create the BIM model. For this, identify the 3D scanning, photogrammetry, wall scanners, robots and drones, thermal imaging, existing drawings, and manual inspections. For all of these technologies, methods, types of data, we have highlighted what are the equipment and technology to be used, how the data is collected, how the data can be processed, and for what BIM use cases you can use that specific data. Moving forward, the data will be used to digital reproduce a HVAC model. For this scope, we developed a tool using deep learning techniques. The status of the tool is TRL5, meaning a feasibility study. From the research taken, there was no reference concerning the detection and classification of HVAC elements in images using this technique. The focus was on object detection and classification as a priority application of convolutional neural networks. For this tool, we have used Google TensorFlow platform. The following slide shows how the labeling and reconnaissance